Hey guys, it's Miss Johnson and I'm here to bring you the second half of our notes for quadratic formula. So yesterday we talked about what the quadratic formula is, or I said it, I should say in the first video. We talked about what the quadratic formula is, what it does for us, and how we use it to solve quadratics. Today we're going to do a couple more examples of that and then a couple of word problems on the back, and then we'll be done with notes 3. So I left off with number 4, and what we talked about in the last video is the fact that our quadratic equations need to be set equal to 0. So I'm going to have x squared minus 2x equals 25. I need to subtract this 25 and move it over so that it is equal to 0. So that gives me x squared minus 2x minus 25 equals 0. And now I'm ready to solve that quadratic. So I have a is equal to 1, b is equal to negative 2, and c is equal to negative 25. So now let's plug that into our formula. I'm going to have the opposite of b, which is going to be positive 2 this time. So then I have square root of, that's b squared minus 4 times a times c. Now we talked about how when you plug this in, you need to make sure you put it in parentheses if you're going to type all of this in. I like to do it in pieces. I like to do this part separate from that part and then put them together so that I have less chance of making a mistake. For instance, if you don't put in parentheses around a negative 2, when you square it, your calculator is going to tell you negative 4. But we all know that a negative times a negative is positive 4. What your calculator is doing is squaring the 2 and not the negative. You've got to group the negative with the 2 so that it squares them both. So be careful of that. But if you type all of this into your calculator at one time, you'll never see that because you'll never see that answer of negative 4 to catch it and say, oh, whoops, that's supposed to be positive. So I like to split them up. I have 2 plus or minus the square root of positive 4 like we talked about, and the negative 4 times 1 times negative 25 is positive 100. We talked in the last video about how this negative times negative gives me that positive, and then 4 times 1 times 25 gives me 100. So that's all over 2 times 1, which is just 2. That's an easy one to fix. So 2 plus or minus square root of 104 all over 4. And then I take the square root of 104, and I have 2 plus or minus 10.2 is what I'm looking at there. Is it 10.2 or 10.02? I think it was 10.2. Yep, just verified that on my calculator. It is 10.2. So now I'm ready to split it into my two different equations. So I have x is equal to 2 plus 10.2 over 4, and x is equal to 2 minus 10.2 over 4. That's x equals 12.2 over 4, which is 3.1. No, I'm sorry, 6. Why do I have over 4? Hello. Miss Johnson, goodness gracious. That 2 should not have changed to a 4. I don't know why I did that. That was just something crazy in my head. That should be all over a 2. My apologies. And then this is divided by 2. There we go. We get 6.1. That looks better. So then I have over here negative 8.2 all over 2, which is negative 4.1. So my two answers are x equals 6.1 and x equals negative 4.1. And again, we talked in the last video about how you can leave these separate if you want, or you could write them together. You would probably see them written together if this were a multiple choice test, but just recognize that they're not an ordered pair. It's not an x and a y. It's two different x values where the solution is 0. All right, let's take a look at number 5. In number 5, I have the equation 0 equals negative 2x plus 3 minus 4x squared. Now, hopefully you look at this equation and recognize that it looks a little funny. I'm going to get rid of this blinding red here for a second. Oh, no, I want this. The thing about this equation is the fact that it is not written in order. I have my squared term over here on the end. So be careful with your A, your B, and your C. Now normally we would want to say A is negative 2, B is 3, and C is negative 4. Not the case. This is not written in standard form. I highly, highly suggest that you rewrite this in standard form before you go any further so that you recognize that A is in fact negative 4, B is in fact negative 2, and C is 3. Now we can go ahead and plug it into the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4 times A times C, all over 2 times A. So that's 2 plus or minus the square root of negative 2 squared is positive 4. Negative 4 times positive 3. That's going to be 16 times 3, which gives me a 48. And a negative times a negative is positive, so plus 48 all over negative 8. When I type that into my calculator, square root of 52, I end up with approximately 2 plus or minus 7.21 is what I have there over negative 8. Now I'm ready to split it into 2 places. X is equal to 2 plus 7.21 over negative 8. That's x equals 9.21 over negative 8. That's x equals negative 1.15. Over here, x equals 2 minus 7.21 all over negative 8. That's x equals negative 5.21 all over negative 8. And I end up with x equals a positive 0.65. So 2 solutions there, x equals negative 1.15 and x equals 0.65. Okay, so take a look at number 6. This is our last just straight quadratic formula practice question before the word problems. In number 6, I have function of x. F of x is equal to negative 8x squared plus 10x. No constant in this question. I only have an a term and a b term. If the constant is not written, we can simply write it in as plus 0. Okay, there was nothing over here that I needed to move over to that side, so it's just a constant of 0. So that tells me my a is negative 8, my b is 10, and my c is 0. So when I plug that in, here's what it looks like. I have the opposite of b plus or minus the square root of b squared minus 4 times a, which is negative 8, times c, which is 0. That's going to be interesting. Let's see what happens there. All over 2 times a. That's negative 10 plus or minus 10 squared we know is 100. Negative 4 times negative 8 times 0 is just going to be 0. Whether it's plus or minus doesn't really matter because if we add 0, it doesn't change. If we subtract 0, it doesn't change. The bottom is 2 times negative 8, which is negative 16. And then I have 100 plus 0, which is still 100. And taking the square root of 100, we all know that. That's an easy one. Square root of 100 is 10. So x is equal to negative 10 plus or minus 10 all over negative 16. So now I'm ready to split. I end up with x equals negative 10 plus 10 all over negative 16, and x equals negative 10 minus 10 all over 16. Oops, negative 16. So that's 0 over negative 16, or just x equals 0. Over here, that's negative 20 over negative 16, which is positive 1.25, or 5 over 4. You can type that into your calculator and write it as a decimal, or you can just leave it separate. Okay, so now we have 2 application questions that we're going to look at and how we can use the quadratic formula to help. Before I do that, I just want to make sure that we're kind of all on the same page. Now, this quadratic formula obviously is a lot of work. We have a whole lot of steps in order to simplify this quadratic formula. But as I said in the first video, this is a formula that is foul-proof. It will work for you every single time, despite what your A, B, and C are, despite what type of quadratic or parabola you're looking at, it will always work. Factoring only works part of the time. Graphing only works when the graph ends up being nice and neat, which is very rare, to be honest. Graphs don't always turn out very nice. So quadratic formula, while it is a lot of steps, it is mindless. It's just a simplifying one equation, and it will work for you every time. Okay, so let's take a look at number 7. We're looking at the power tower ride at Valley Fair, and it takes riders to the top of the tower and drops them 60 feet at speeds reaching 80 feet per second. The function that models this ride is h is equal to negative 16t squared plus 80t plus 60, where h is the height in feet and t is the time in seconds. About how many seconds does it take for riders to drop from 60 feet to 0 feet? So you are given the equation. The function that models is this. That makes life really nice because you've got the equation already written. You want to know how many seconds does it take for them to get from the starting point to 0. Okay, so that means 0 is my h. When I plug that in, it looks like this. 0 is equal to negative 16t squared plus 80t plus 60. So now I want to solve this. I need to figure out where this thing equals 0. You can solve using graphing, you can solve using factoring, or you can solve using the quadratic formula. Now, when I look at this, graphing and factoring look like they're going to be kind of tough because I have some really big numbers to work with. I don't want to work with those, so I'm going to use the quadratic formula. So I have x is equal to the opposite of b, that's negative 80, plus or minus the square root of b squared, 80 squared, minus 4 times a times c, all divided by 2 times a. Big numbers here, but that's the beauty of calculators. They do the work for us. So 80 squared is going to be 6,400. And then minus 4 times 16, negative 16 times 60, minus a negative is plus, and 4 times 16 times 60 is 3,840, all over negative 32 there. That's x equals negative 80 plus or minus the square root of 10,240, all over negative 32. When I plug the square root of 10,240 into my calculator, I end up with negative 80 plus or minus this 101.2. So this is the point where I'm ready to split it. So I split it apart. I've got x equals negative 80 plus 101.2 over negative 32, and x equals negative 80 minus 101.2 all over negative 2. Negative 80 plus 101.2 is 21.2, so x equals 21.2 over negative 32. That's x equals negative 0.66. Over here, I have x is equal to negative 181.2 all over negative 32, or x equals positive 5.66. Okay, so we have our two answers. This is one possibility and this is another possibility, but I'm not going to circle them yet because I want to figure out what the question is asking me. If you go back to the original question, it asks for about how many seconds does it take for the rider to fall to the ground. How many seconds? So I have a possibility of negative 0.66 seconds and positive 5.66 seconds. We all know that time cannot be negative. It is not possible to have a negative time. So this answer is out. I can't use it. Okay, my only possible answer here is this one, and that's how I'm going to write this out. 5.66, don't forget to label it seconds. That is your answer here. Okay, one last question. Number 8, it says, a stunt person attached to a safety harness drops from a height of 210 feet. The function that models the drop is h is equal to negative 16t squared plus 210, where h is the height in feet and t is the time in seconds. About how many seconds does it take for the rider to drop from 210 to 30 feet? This is interesting. Okay, so now we're dropping from 210 to 30. We're not so concerned with all the way to the ground. We're concerned with when do they get to 30. So 30 is now what I'm going to plug in for h. Again, the equation is given to you. That makes life really easy. But I want to know when the stunt person is at 30 feet, not the ground. So I have 30 is equal to negative 16t squared plus 210. And I'm going to solve this using the quadratic formula. I know that if I want to solve this, I've got to move my 30 to the other side. So I'm going to subtract 30, and I have 0 is equal to negative 16t squared plus 180. All right, so now be very careful with this because if I take a look at this, my brain automatically tells me this is my A, this is my B, and then what's my C? The problem with that is that there is no t with this b term. So this is actually your C term. Your B term is 0x. And again, if you want to rewrite that, that will show you. I guess it's a t, not an x, but you get where I'm going here. So I have negative 16 for my A, 0 for my B, and 180 for my C. Be very careful with that. This has no variable with it. That means it's your constant at the end. Now I can go ahead and plug this into the quadratic formula. So I have x is equal to the opposite of b, that's negative 0, plus or minus the square root of b squared, 0 squared. That 0 in the middle is going to make our life pretty easy here. Minus 4 times a times c all over 2 times a. So then I have x is equal to, I'm just going to write in 0 because we all know that negative 0 doesn't really exist. It's still just 0. This is 0 squared, which is 0, and then negative 4 times 16 times 180 is 11,520. That's an 11,520 there is what I get there. That was a negative times a negative, which gave me this positive. And then in the bottom, I have a negative 32. So putting those together, kind of an obvious one here, 11,520 all over negative 32. So now take the square root of that 11,520. When I type that into my calculator, I get 107.3. So 107.3. So 107.3 is what I'm looking at there, all over negative 32. This is where it splits. Now it seems silly to split it because what happens here is I have x is equal to 0 plus 107.3 over negative 32 and 0, x is equal to 0 minus 107.3 all over negative 32. But this is actually two different things because 0 plus that is going to be positive 107.3 over negative 32. And this one's going to be negative 107.3 over negative 32. Now again, in this question, we're looking at time. We want to figure out when the rider hits that 30 feet mark. So I know that this one right here, even if I plug it in, I can stop. I don't need to plug it in because I have a positive divided by a negative, and a positive divided by a negative gives me a negative answer. That's not going to help me. But over here, I have a negative divided by a negative, which gives me a positive answer. So when I plug that into my calculator, divided by on that negative 32, I end up with 3.35. So that is my answer. All right, so that takes us to the end of our video. Thanks for listening today. Don't forget to check your note sheet off with Ms. Johnson, and I will see you all later.